Hello, and welcome to another episode of Hacking with Friends. My name is Cody Kinsey. I am a security researcher with Varonis, and this is Michael, our production assistant and camera rescuer on the show.
Okay. Yeah, sure.
All right. Today, we are picking up the ruins of the show we tried to film yesterday. I had a really interesting one lined up for you guys where we were going to spy on a webcam by basically using Wireshark to decode the traffic and do all this cool stuff where we'd basically be able to see what some webcam on a network is seeing, provided that we know the password to the network. Now, this sounds really cool. It's quite complicated to set up. It took several hours. We got 50 minutes through the live stream, almost all the way to the end.
All the way to the final step.
Would not work. Would not work. I watched my own tutorials. I cursed at the computer. I tried a new computer. Nothing would work. So we're going to figure out why the laws of science have been broken so badly to purely spite me. But in the meantime, we're filming this episode to make up for the fact that we cannot get the last one to work whatsoever. That's also why we don't film all of these completely live, because if you guys just want to watch me curse at a computer for 45 minutes or so, for one, I don't think I can get paid for that. But if you do want to watch it, let me know and I can create some sort of like other account. But it's not this one. So today we're going to focus on some things that actually work. And in times of trouble where I have to find a new cybersecurity tool, Michael, where would you go to find something?
Kitploit.
Kitploit.
Indeed.
So we really like Kitploit for a number of reasons. And this is not to say we endorse them. What we're saying is if you're a cybersecurity researcher or if you're someone who might usually be, I don't know, trolling around like GitHub or Twitter or something looking for new security tools, then Kitploit kind of already does that for you. And there's been a lot of times where we've identified some really cool and interesting tools that have recently come out from developers who, you know, maybe don't have a lot of love on their project yet. And again, some of these are flaming piles of trash. Like Kitploit shows off some... Kitploit shows my code sometimes, if that tells you anything. So, you know...
But your code is the best code.
My code is duct tape Python strapped to an API I barely understand.
Yeah.
And that's okay, because the OSINT tools I make are great and fun for beginners. But that's just to say, some of these projects are made by beginners, so it can be the case where, you know, you pick something up and you try to run it and it just like will not even run. And also you're going to want to look at these and make sure that you understand at least a little bit what's going on behind the hood, because again, not exactly the most discerning of publications.
They could be malicious for all you know.
Exactly. Yeah, that's the implication. Yes. So today we're going to focus on a couple tools that I think are really, really interesting. And the one we're going to really check out is kind of a twist on something I saw demonstrated, gosh, like maybe like 5 or 6 years ago for the first time. Michael, have you ever heard of an application called Chirp?
Yes. But that was like a radio thing, so I don't think we're talking about the same Chirp.
Well, the application is on a smartphone.
Okay. The one I know is like for programming Baofeng radios.
Well, no, not that one. So if you were thinking of that one, that's not the right one. The one I'm talking about is an app on smartphones that was first available, again, like maybe like 5 or 6 years ago. And what it allowed you to do is send information like photos or other things using audio. So it's kind of interesting, like...
like a modem, a dial-up modem.
Sort of. So the way that it works is actually a little bit more intricate than it seems right off the bat. But yes, essentially what it's doing is it's encoding information in audio, sending it, and allowing two devices that are in proximity to communicate with each other. Now, the way that this actually happened on the app was a little bit less cool. What would happen is you would, let's say you have a photo you want to share with someone and they're nearby, but you don't have the opportunity to like share details or you don't want to, like you just want to send a file or something like that. You could play this audio tone, but what that audio tone is actually an encoded URL. So this app would like take the photo, upload it to a third-party website.
Why not just give them a URL? Like, why chirp it?
Well, because the phones can be right next to each other, and you don't have to be like, all right, the URL is blah 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 blah,
Yeah,
some
yeah.
like incredibly long thing. Like like the concept was like, okay, imagine that you need to direct everyone to a website or whatever else, and or a particular piece of media, a PDF maybe, and
Yeah.
you're in school.
Or-
You could just send
yeah.
this audio tone, and everybody would sync up on that exact website, which is kind of cool. The thing is, it wasn't actually sending very much data. It was sending a very short compressed bit of data, and then it was linking both parties to the file. So you still need an internet connection. There's like other stuff that's involved here that makes the whole thing like a little bit less cool than it initially seems. But the concept is like out of band communication. Like how can you use a device like a smartphone or a computer to do something that, might be not expected? So let's say that you're at a secure lockdown facility and it's air gapped and there's no way for you to network on this computer.
Right.
Well, if it has the ability to play tones, then you could actually get a fair amount of information out if you really wanted to. And the way that you could do it would be untraceable. And that's really what we're talking about here today is how you can use out-of-band communications to, let's say that there's really intense monitoring of wireless stuff and there's like no like sorts of other media allowed. You can create a link between two devices that is really, really sneaky. And I like this project we're going to go over today because it kind of shows off how you can use the hardware of a device for ways that were not intended by the manufacturer.
Yeah.
And I think that that's like very like pure like hacker stuff right there, where you're able to do something completely new using sensors that kind of weren't designed for this.
I've actually seen similar projects on like Hackaday and stuff, but they were using LEDs and blinking them.
Yes.
Because it's very common for devices to have LEDs. Sure, you can do like kind of Morse code, binary code with just blinking the LED, but then also if it has colors, you could incorporate the colors and you get okay data rates. But what's better with blinking LEDs than like chirp or something like that is you can do it from a longer distance, depending on like, because the limiting factor then is more like the receiver, whereas it seems with audio, like, you're going to be limited in how loud you can chirp, right?
Right, and there's a lot of ways you can exfiltrate information out of band. Another one is QR codes. QR codes are great because let's say that you have access to like a video camera. I've seen really weird solutions where it'll just encode the information into QR codes and rapidly play them almost like a video. And if you're just there recording, it'll basically just record all the information as a video file and you can go back and decode it later. Pretty cool.
That's sneaky.
I mean, most modern like security cameras that configure, they have to solve a problem. They have to send data about the wireless network they're supposed to connect to without a keyboard or any sort of interface. So a lot of them, you'll get the app, you'll type in the information, it'll generate a QR code, and then you literally hold it in front of the camera, and the camera will decode the information and connect to the wireless network.
That's how, when I was doing my IoT smart home project that Kody absolutely destroyed, one of the devices I had initially worked with was the Waze camera, and that's how it would connect, is you'd like generate a code or whatever. But yeah, so like there are legitimate uses for this sort of thing. Like I know the Electric Imp project was one of those that blinks the LED to transmit the Wi-Fi password so that you can get an IoT product on a network.
Yeah, definitely. And LEDs are also a way you can do this. And there's some advances in things like Li-Fi, which use imperceptible flickering or changes in light to transmit data. And that's really, really cool. And that's more of a solution for a relatively high throughput data connection in a room or something. What we're talking about today is going to be more like super sneaky, the ability to exchange a small amount of data that allows for maybe a stronger individual connection. So let me give you a kind of use case here. Let's say that there's a Wi-Fi network that people can connect to, but they want to share data between each other, and they don't want to do it over like a carrier network, so they want to be discreet about it. But actually finding each other on the network is difficult. How do you do that? Well, the project we're going to cover today attacks this in a really interesting way. It uses what I consider to be a flaw or a leak in WebRTC in order to sync up with other devices using audio. So basically what happens is you open a browser on your computer. You would open a browser on your computer or your phone, whichever, and then, provided you're connected to the same Wi-Fi network, you would select a file or something you want to like send to the other person, and then you would start playing a tone, and the nearby device would use its microphone to interpret the tone, find your IP address on the network, initiate a peer-to-peer connection, and then download whatever file you were sending.
That's pretty cool.
Right?
So
I mean, this is it's an analog of other technology as well that is wireless. So there's AirDrop and stuff like that kind of does the same thing. But what's cool about this is it's audio, so it's out of band. So if you're doing wireless monitoring, or if you want to find something that's like completely not using electromagnetic signals that are going to be like found by
Right.
anyone. It's a really cool way of being able to negotiate that initial connection. And you can actually send just data too. So while it is much slower, and that's the reason that we're using this for kind of like keying and to like maybe exchange short local data in a way that's hard to overhear outside of a small confined space. For electronic eavesdropping and stuff like that, might be a huge advantage to like manage to negotiate secrets in a way that is not very verbose, but that's just the part of the conversation that needs to not be transmitted wirelessly.
I would say that microphones are everywhere today. Like with smart speakers, your smartphone, like your assistant listening all the time. So like, yes, it is a little more covert than something that uses Wi-Fi. Because like I had thought about like the pirate box. Like why wouldn't you just use a pirate box? It's like a wireless dead drop intended for that sort of thing as well. But yeah, so you're not going to be
because you're negotiating. You're
with
negotiating but you're negotiating a peer-to-peer connection rather than using like a group
a
connect.
third party.
Well,
thing,
yes, and also the use case would be if you had like a pirate box that a bunch of people were connected to, and instead of just dropping a file into the group chat effectively where everyone can see it, if you wanted to just negotiate a connection directly between somebody else on the network, you could, via proximity, initiate that connection, and it would be kind of like a link just between you and that person.
Did we do a video on the pirate box?
Yeah, we did.
Okay,
not
that
on SecurityFWD though. It was on No Light. But
okay, well, I think we might have a live stream on it. If we don't, I'll make one and link to it.
Yep. So okay, so that's kind of the two things we're going to be talking about today about this tool: sending data raw, so actually transmitting like full sentences and maybe even secrets, and then actually just negotiating a small link to make more of a peer-to-peer based identification and sharing system. And again, like there are systems like AirDrop that kind of do a similar thing, but only between Apple phones. What I like about this is, for one, it's a very hacker project, and for two, I feel like it's an upgrade on some of the previous stuff that has been developed. Now, if you wanted to take it even further, then being able to establish a peer-to-peer Wi-Fi network based on audio tones, like basically negotiating a connection between two disconnected devices so that they can just connect directly, that I think would be a really welcome upgrade to this project, because it means you don't need to have a third-party Wi-Fi network, and you can eliminate some of the other stuff that's kind of annoying around the RTC web hack. Again, this also doesn't work on absolutely every device, because this is what I would consider to be a leak, and some manufacturers are now stepping up to make sure that the latest version of WebRTC is implemented, and that does not allow some of the behavior that this relies on in order for the slickest part of this to work. So as this project kind of runs into some problems with the underlying technology it's abusing in order to make the IP address stuff work, I would hope that maybe it could be done on, I don't know, like a peer-to-peer basis. So you could actually just negotiate a connection with a nearby device just by playing a tone. That would be really awesome. Like imagine if you could just like whisper to your refrigerator and it would like connect to your phone and like let you do stuff to it. Like
yeah,
like,
I guess it
would be kind of cool.
Like, it just seems like a throwback to the 80s for no reason.
I kind of like it though, because like so many devices, even low-end devices, have like a microphone and a speaker. It's just like really cool that there's ways of using things aside from all the wireless interfaces to do this sort of stuff.
Yeah, that could be cool if like smart speakers could just like beep at you and then like something would pop up on your phone. There does seem like more elegant ways to do that, but sure.
Yeah, so okay, let's go ahead and go to my screen. We're going to take a look at this project. And you can see that it's been, oh no, watch me like complain about the error. Yeah, you can see that
since this has been supported.
Yeah. Well, months and not years. So that's generally a good sign if it's been months and not years. But again, 10 months. So still,
right,
not maybe the most recent. And already this project was updated to mention that it was not working on some versions of browsers. But again, I think this is so cool, and I really like that they've also developed a command line tool for it. So so you can see there's a description of how it works. WebRTC technology allows two browsers running on different devices to connect to each other and exchange data. And that's really the core of this. If you're both on the same network, there's the potential for you to just connect directly with another device and just share stuff. And that's really cool. But in order to make that happen, you need to know the IP address of the other device. So this cool hacker has solved that problem by using audio tones in order to initiate the connection. And that's really cool, and also an interesting way of dealing with the limitation of how much data this can actually send, because it's a relatively small amount of data for how long it takes to send, which you guys will hear in a bit.
I was gonna say, how does it like decide like who speaks when, or does it even address that problem?
It negotiates it, yeah.
Yeah.
So you can see that there's kind of a description of like what's contained in the package, and the total size of the audio packet is 112 bytes.
That's microscopic.
Yeah, it's very small, and the packet can be transmitted in 5 to 10 seconds.
That's slow.
Yeah, it's pretty slow. So that's why this is usually limited to sending things like IP addresses or maybe like some sort of like syncing thing. Although, again, you can send data directly over this. So if you wanted to send some sneaky stuff over like a radio maybe, then, this is encoded and not encrypted. So theoretically, like, maybe
this seems slow even compared to like the dial-up modems that they would have used for like DSL and stuff like that, right? Because that was at least like kilobits.
I don't know.
Right?
Sorry, I just used dial-up modems. I'm not a.
You're not that
dial-up
level of
modem
nerd.
head. Yeah, sorry.
You don't like freaking?
Yeah. So all right. So this is mostly based around getting the local IP address, and then it comes with the command line interface tool WaveShare. And I thought this was really cool. I was playing with this. The build is relatively simple, although there was an extra step that wasn't documented here. I had to install something that it complained about as soon as I tried to run it. But yeah, you just do a git clone. You do this command next to make the directory and cd into it. You configure the file.
Zoom in. Whoa.
Happy now?
Yes.
Okay. You configure the file and then you make it. And once it's made, you can just run it with this command. Now, I found that there are a series of different arguments that you're supposed to be able to run with this. And that's what I was complaining about in the previous screen. It seems like all of the arguments don't work. So if you're trying to specify like a particular audio source that you want to use, that's not going to happen. It just errors out and says something annoying. So for now, my solution has just been, for example, we're plugged into an HDMI source and it really wants to play to that HDMI source. I just unplug the HDMI source when I run it and then plug it back in, and it seems to work. A little annoying, but again, this hasn't been updated in 10 months. So hopefully this kind of stuff inspires you guys to try making interesting new tools. Like I've seen stuff like this turn into like really interesting out-of-band exfiltration tools and all sorts of other stuff. So yeah.
Well, like I always try to say when we're doing these projects, it's more about like the techniques and strategies than the step-by-step, like run this code now, right? Like learning, oh wait, hey, maybe I can use audio to exfiltrate data. It is more of like the notion, and then trying to use that yourself. Obviously, love for y'all to follow along, but
right. So okay, so here are the limitations of this program. For one, these operating or
Chrome or Firefox.
No, sorry. So these are the issues that have come up in terms of WebRTC being updated. It's not all of Chrome or Firefox. It's specifically Chrome/Firefox on iOS. So what that means is that Apple in particular has really gotten on the WebRTC leak and made sure that especially its mobile devices are protected against this. Now, Android devices are, let's just say, more subjected to trickle down than some like a monolithic carrier that just like puts out an update for all their devices. So a lot of Android devices will still be able to use this. And I've tested this as of last night on a Pixel, and it still works. So this is not a total killer on this, although you can see that, we're going to need to make some updates to this if it's going to work forever.
That's what I was saying. It's like the two most common browsers, but then,
on iOS. So we also have ultrasonic sound transmission doesn't work on most devices, but it does work on some. So that means that there are some noises that are like barely within or just outside the human hearing range that can be used for this. So this is going to sound like a shrieking, weird noise that is obvious, but there are devices that are able to basically use tones that are not easy for humans to hear to exchange this data. So if you have a really long piece of data you're trying to exfiltrate and you don't want to just like have it sound like a router or like an old modem, then you can, if the device supports it, try to use ultrasonic tones to make it less obvious what you're doing. Let's see.
So like the teen noise or the way bats communicate.
on
basically.
mobile using Firefox, the page can remain running in the background. All right, so I also wanted to show how we found this. Again, a shout out to Kitploit. We really like them. They have lots of interesting tools and many terrible ones too. So some of the things we're going to be covering on the show we have found from here. And ooh, like a WPA3 dictionary cracker. Don't even know what that is. Don't know if it's a good idea, but we'll probably find out at some point on the show.
Yeah.
Yeah.
The way I usually use this is if you go up a little over to the right, they have the popular. Oh wait, are you on the main page, the home page?
No, I'm
No.
looking at tools.
Just below that ad on the right is like the 5 most popular. I usually mainly just look there because over here. Oh, you're inverted. But yeah.
Oh,
so right there, those are just like the 5 most popular. So you let the crowd do some of the vetting for you.
Yeah, that's nice. So like for example, a vulnerable crypto app, like that's great for people who are interested in like pen testing and doing bug bounty stuff. So yeah, you can find some tools that have kind of floated to the top here and not waste your time. You can see the one we're covering is like the least popular of the most popular. So, you know, being
and also like
edgy.
another thing Kitploit will do is at the end of each year, they'll do a roundup of the most popular ones from that year. So that's another good way to find some stuff. By that time, they're not like bleeding edge, obviously.
All right, Michael. So in a browser, I need you to go to this GitHub.
Okie dokie, but I'm on Mac OS, so it's not gonna work.
I'm on Mac OS too.
Okay.
That's so crazy.
Okay.
It's almost like you didn't read. If you read at the bottom, you'll see that only Safari doesn't work on Mac OS. See?
I thought that was
Safari. Is that Safari?
So it's not. It's Chrome and Firefox on iOS.
iOS. Is that an iPhone?
Okay, yeah.
Your iPhone's
these,
huge, bro.
I don't know these Apple products.
All right, so iOS is for So
what
this should
GitHub page am I going to?
Waveshare. Just type GitHub space Waveshare. Oh, it's all one word, but it'll find it.
Whatever.
Yeah, first one. All right. So what I want you to do is go down below the proof of concept demonstration, and I want you to click on try it yourself.
Try it yourself. Where? How?
Try it yourself.
There we go. I gotcha.
Cool.
Allow? I can't do that because then that will kill our recording. MacBook Pro microphone. Should I?
Sure. Okay. So this is how it works. Okay. Basically, we get this interface, and between 2 devices, and I tested this on my Android phone as well, we should be able to send files. So I'm going to press init. I'm going to choose a file, and Michael won't get to see this before. We're on your screen, right?
No.
Oh, well, that's too bad. I guess Michael will get to see it before.
Well, I'm looking at my screen. I can't see your screen right now, but the people will see your screen.
Okay, cool. So, all right, so we can pick whatever file we want. We can see our local address here. Basically, this also does a series of checks: output, capture, browser, WebRTC. If one of these isn't checked, like if this isn't checked, then it's not going to work. So go ahead and click init, Michael.
Okay.
Cool. And then allow. All right. And what browser are you in?
Firefox.
All right. I am not. Let's do this in Chrome.
Okay.
Just copy and paste the just because I see that WebRTC is yellow. All right. Well, Michael's getting that done. So what's going to happen here is once I select my local IP address, this is what's going to be broadcasted when I press the broadcast key. And then as soon as the connection is negotiated, it should try to send this file. All right. That's looking better. Go ahead and allow that again.
I don't know which microphone it's trying to use. So if I accept the wrong one, then our audio is going to die. I'll just allow, I guess, for now.
Okay, cool. You're online. So go ahead and select the IPv4 address instead of the IPv6 address. Great. And okay, we should be ready to go. So I'm going to press the broadcast button, You've already hit init, right? Yeah, so could we switch over to your screen?
No, we don't have that set up because I was not told to set that up.
Oh, okay. All right. Well, I'm going to press broadcast.
It says handshake in progress.
I don't want you to dictate everything on your screen to me. Okay, cool. So it looks like you didn't find any active peers. So what I'm going to have you do, since you didn't set up the screen, is why don't you send me a file?
Yeah. Okay.
Go ahead and...
No, I got something that says receive file from, and then your IPv4 address.
Oh yeah. Well, no one's going to see it, so go ahead and send me something instead.
Okie dokie. How do I do that? Choose a file?
Yep. Choose a file.
Okay. And it has to be like a tiny file, right?
Nope, it doesn't have to be a tiny file. Please don't make it like a video file. Make it an image, though. We don't have all day. So the file is
okay.
Hey, Video Downloader Plus contains malware.
Yeah.
Good to know. You heard it here first. Yeah. Okay. So basically,
I don't know
what's actually happening.
What this image is because I can't see it. So.
Oh well, that's very dangerous. I guess we'll see it on my screen on the live stream.
Yeah.
You can drag and drop stuff into that window too.
Can you?
Yeah, you can.
Okay.
Just in Finder.
Desktop. Let's do one of the comments from one of our videos.
Yeah, sure. Okay, so Michael's gonna try to send this thing to me. Just drag and drop that in. No, into the window. Yeah, there. Okay, good. Whew, okay, all right, we're gonna try it.
Okay,
so
broadcasting.
All right. Cool. All right. So again, what happened was that wasn't the whole file being broadcast. That was just my IP address. So I'm clicking on receive. Okay. And you can see that now we started downloading. So what just happened? Michael transmitted his IP address and the offer of sending a file to me, and then I sent my IP address back, as well as basically the receipt. I'm like, yes, please give me that. So let's go ahead and try to open this. Hey, there we go. And
cool.
It's the exact file Michael sent me. And in fact, you can do a larger file. Is there a small video file, perhaps?
Yes, indeed.
So I just want to show that this is actually fairly efficient if you're using it as like a shortcut to, be able to like, oh yeah, good. To be able to, just like share a file or something like that.
Choose file. Yeah, I mean, it is a little cumbersome because you do have to have them go to the web page first. So like if I...
How would you do this? Let's see. Okay, go ahead and broadcast. All right.
It does make me
We're
feel
gonna
very
select to receive a file.
cyberpunk, though.
All right, and we're downloading the file, and it's fast.
Yeah. Well, that's because I think we're on the local network, right? So like,
yeah,
it should go very fast.
Cool. Yeah, and then we have this. Oh no. Oh, it's opening in Windows Media Player.
What?
No.
What have you done?
No. Sorry, it's not happening. Nice try, Windows. Sorry, Parallels likes to try to make you feel like your computer is all like cohesive, even though there's multiple operating systems on it. So I'm sorry, we're not opening that in Windows Media Player. That's ridiculous. But you guys can see that we can even exchange a video file relatively quickly, provided we're on the same network using audio tones.
So it's not really using the audio to transfer the video. It's
it's not
using the Wi-Fi.
That was never advertised.
Yeah.
So, okay, so let's go into actually doing what Michael's flapping his gums about, which is actually using the entire, the audio tone to send the entire message. So once we follow the instructions I went over before, we should be able to just go into the folder that it's hosted and run this command in order to do this. Now, the problem, as I've already established, is that you guys aren't going to hear it, because the way this works is it'll find HDMI 0, which is just output to the recorder, playback device 1 and 2. Of course, we need 1, and no matter what I do, it will always grab 0. So if I type something, it will do nothing. So the solution is, well, Michael, let's go away from my screen because it's going to...
Hello.
Yeah, it's going to go away for a second. So I have to unplug my HDMI, cancel, and then run this again.
Yeah, we were working on another solution, but time crunch.
Okay, so now I'm going to plug this back in, and because it has successfully selected the correct device this time, we're actually going to be able to use it.
Woot! We see stuff.
All right. So now let me try typing something. And I was going to make Michael install this on his computer, but it would be completely pointless because, well, he can't show his screen. So you'll have to believe me that these two windows are going to be sending data to each other just using sound. One is going to be listening to the microphone while the other broadcasts. And this time we're not using some fancy link in order to create a connection and send the data. We're just sending data using this protocol. And again, it is not the fastest. So let's just do...
I mean, if we really need to, I can reconfigure the setup in like 10 seconds.
All right, so we're going to send a message.
Michael wasn't told to set up a screen.
And then we can respond with a retort.
So you'll only have your
works.
computer talking to itself?
Yeah.
Via
And
audio.
you can also hear that those tones are triggering this poor thing. It's just like, what is someone trying to send me that was not an IP address?
So these are different programs.
Yes, so these are
Yeah.
different implementations. This is a specific implementation that's using this protocol to send connection data, so it can initiate a file transfer. Whereas this is just using the raw protocol to send messages. So, of course, there are also limits. So let's go, I'm going to go out of this one, and I'm just going to take some text from this. Let's go ahead and see what it looks like in order to try to send a larger amount of text.
So in a way, this is like what aliens might sound like.
Yeah, aliens could talk like this if they were nerds. Let's see how fast it is. But you'll notice that this is going to be truncated, which makes me mad. So we can see it didn't send that much data, but it was probably faster than me just like saying these words, I guess.
Yeah.
I guess
Faster than you reading them.
Yeah, I guess I'll try. I read pretty fast though, so let's try just sending the text that's going to be sent.
Oh, do you want to actually like try to time it?
I'm gonna, well, I mean, not time it. I'm just gonna say it. The web RTC technology allows two browsers running on different devices to connect with each other and exchange data. There is no need to.
I love that you can distinguish that end tone it uses as well. It's
Yeah,
different from all the
I'm
others.
happy that even with me talking over it, it was able to do it. The WebRTC technology allows two browsers running on different devices to connect to each other and exchange data. There's no need to.
That's probably because it's using that special. So there's the frequency range that humans can hear, and then
It
there's
thinks you're talking to it.
and then there's a frequency range in which humans can speak.
Uh-huh.
So it's probably using.
Michael, you made it sound like the robot.
I am.
Guys, Michael speaks its native language. We might need to have a conversation with Michael about why he speaks native computer.
Yeah.
Hmm.
That's how I hack so good.
Right. So I feel like you can also speed this up. There's some other stuff like if I'm yeah, so there's some other flags on this that I haven't been brave enough to try just because the first one I tried didn't work, and I'm in the process of complaining about it on a project that has been updated in 10 months.
We have time to show.
Well, no, we don't. Because it's not going to do anything.
Okay.
But yeah, so that is kind of a good overview of out-of-band communication when it comes to using audio tones. Again, we've gone through some other ones today that can be used for like transmitting information via light. You can transmit information via, oh god, what else did we go over?
I've seen even, well...
QR codes,
the
which
one-
is another cool one. But it
Yeah.
seems like, you guys, it seems like if you really wanted to, you could just use speech to text. Because if it talks as fast as I do or faster and another machine can just decode it, then
Yeah.
that might be a way to exfiltrate data slightly faster than us.
If-
But if you're just sending like
Yeah.
an IP address or a number or using special characters, or if it's like a piece of code that you're exchanging, then you probably shouldn't be using speech to text or something like that. So I do understand. But again, I was able to say the sentence that it was broadcasting faster than it was. So this is not exactly like, a super fast way to upload like a video file.
If y'all are interested in this type of stuff, look up the channel Future Interfaces group. They actually have a bunch of research papers about using stuff like the vibration motor in a phone vibrating, and then you can shine a laser at that phone and the vibrations of the phone will give off data. Yep. You can put reflectors on surfaces and you can get all kinds of data, so you could exfiltrate data through like physical vibrations of an object. There's other things like capacitance and all these interesting sorts of methods that you could use if you want to be really creative about how you exfiltrate data. So definitely worth looking into.
Yeah. So I really like sneaker nets. I like sneaky ways of exchanging information. I love exfiltration.
Sneaker nets? Is that like the official term for this?
So sneaker nets are networks that are designed to be out of band that transmit data, but sometimes with very high latency or other trade-offs in order to be secure or clandestine. So I really think they're cool. It's one of my favorite things to study. And this is like one of the ways you can establish a link with other devices in order to exchange data that is probably going to be really out of band for what's expected.
You could also look into ham radios, because what is it called, like ARPANET or something like? There's some amateur radio networks that basically use the amateur radio band, but then they can still do packet data over that. It can't be encrypted because of the rules of using amateur band radio, but that is, technically speaking, out of band because most people aren't looking at that band, right? And then also, if you were to be a black hat, you could use other radio bands that you're not allowed to technically use to exfiltrate data in a way that people might not be looking at, because like the electromagnetic spectrum is so wide, right, that you can't monitor all of it everywhere in the world all at once.
Yeah, in fact, one thing that one tool I really liked I saw at DEF CON was just a little Raspberry Pi that was using a wire stuck onto one of the pins to broadcast out of band information on like some random FM frequency that, was not going to be, watched by any sort of like monitoring or anything like that.
Because who walks around with an FM radio tuned to that specific channel everywhere, right? So
so really sneaky stuff that you can do. I mean, I'd love to do more stuff on like kind of exfiltration as well. So DNS exfiltration is really cool. We could do something on that. We could also do something on steganography if you guys are interested in that. We could I could try to track down that cool QR code thing I mentioned that just saves a bunch of data by generating a bunch of QR codes in like a video stream. Like all really cool stuff. So if you guys have a favorite method of clandestine exfiltration or sneaker nets or anything like that, please let us know in the comments. I would love to find some more projects to cover for you guys on the show. This one is relatively brief, but trust me, you guys do not want to watch me just devolving into cursing at computers as the last recording went, because Wireshark, man. Wireshark.
Gotta love it. Okay.
Cool. All right. So I think that's pretty much all we have. So I also have to shout out, Killian has been our guest on multiple streams, and he's starting to do his own thing on the Varonis channel. So if you want to check out the threat update, it is a really cool way of finding out basically the kind of threats that companies like Varonis that are protecting lots and lots of really big players are discovering. You'll be able to find out what's happening in the cybersecurity world, kind of how these threats work, and what people are doing to defend against them. So you can check out the Varonis brand channel on YouTube. It has some of our friends on there that are doing some really great work, and you'll probably enjoy that as well.
And that's just Varonis. And also I believe he's doing something called Reconnect. So it's like Q&A after some of the Connect events that Varonis does as well. So all interesting stuff, so be sure to check out the Varonis YouTube channel. Yeah, and again, if you guys are joining us from the live stream we did on Nullbyte, it's really great to see the over 100 subscribers we gained in a single day from that. So welcome to the stream. Thank you guys for joining us. Make sure to shout out in the comments. And when are we doing our next Q&A? Is it next week? Next Wednesday. Yeah, so next Wednesday, we're doing a Q&A on the SecurityFWD channel. So I hope you guys will join us there with your questions, comments, and suggestions to blink more. And yeah, we'll see you guys then. Thank you so much for joining us.